Example 53 is examining two functions, and we're going to be performing operations between those two functions. So our first function, let f of x equal 3x squared plus x and g of x equal x squared minus 4. We're going to evaluate each of the following and eventually simplify. So we're going to create a new function j of x by adding together f of x plus g of x. So I'm going to put parentheses around the f of x function, 3x squared plus x, plus, and then my g of x function, I'm putting parentheses around it, x squared minus 4. Now it may seem a bit unnecessary here, and it is, but later on when we do the other operations, you're going to want the parentheses on. So it's just good habit, good practice. When I combine like terms, you're adding the coefficients in front of the variables with the same power. So I'm going to have a 4x squared plus 1x minus 4. When you subtract, the parentheses are very important. So I'm going to take f of x again in parentheses, 3x squared plus x, minus, in parentheses, the g of x function, x squared minus 4. Because there's a negative in front of this second set of parentheses, I have to distribute the negative sign. You're negating the entire function g of x, not just negating the first term in that function. So I have ultimately 3x squared plus x minus x squared plus 4. Combined up your like terms and you have 2x squared plus x plus 4. X squareds can be subtracted in this case. For the next function, p of x, we're subtracting again, but the order is different. So I have to pay attention to which function I put first. G of x is my x squared minus 4 function, in parentheses, minus my f of x function, again in parentheses, 3x squared plus x. Distribute the negative sign. So I have x squared minus 4 minus 3x squared minus x. When I combine like terms, 1x squared minus 3x squared is negative 2x squared minus x minus 4. If you look at the difference between these two answers, we switched around the subtraction, and ultimately what that did was it negated all of our terms in our answer. For m of x, we're going to multiply f of x times g of x. So again, in parentheses, the f of x, 3x squared plus x, the g of x, x squared minus 4, and here we need to again get rid of parentheses. We're going to FOIL. So first, 3x squared times x squared, 3x to the 4th. Outside, 3x squared times negative 4, negative 12x squared. Inside, x times x squared, x to the 3rd. And then last, x times negative 4, negative 4x. None of these have the same power, so we can't combine any further. If you wanted to, you could write it in descending powers of x, but it's not necessary. For letter E, n of x equals this quotient, f of x divided by g of x. Our f of x and our g of x will just be written in that order. So f of x on top, 3x squared plus x, g of x, x squared minus 4. Now you can't pick and cancel anything unless you factor first. So if I factor the numerator, I can take out an x, and I'm left with 3x plus 1. If I factor the denominator, that's the difference of two squares, x plus 2, x minus 2. I can only cancel factors. So at this point, none of my factors are the same. So I could have stopped here for that answer letter E. But I wouldn't have known that until I tried factoring to see if I could cancel. The last part here, what number or numbers will make n of x undefined? Undefined means you're dividing by 0. And then determine what the domain is in interval notation. So I look at the denominator, x plus 2, x minus 2, and if that's equal to 0, then it's going to be an undefined fraction. So I'm really solving this equation, x plus 2 times x minus 2 equals 0. Set each factor equal to 0, solve for x, and these two numbers will make your fraction undefined, -2 and +2. If I plug 2 back here into this denominator, 2 squared minus 4, 4 minus 4 is 0, can't divide by 0. It's going to be undefined. Same for -2. -2 squared is +4, 4 minus 4 again, 0. I can't divide by 0. So the two numbers that will make n of x undefined are these two. What is the domain of n of x in interval notation? So think about it. These are the two numbers I can't use. So let's check it out on a number line. I can't use the number -2. I cannot use the number 2. Let's put all open dots here. But I can use any other number to plug in. Like if you were making a T-chart, you could pick any of these other numbers that are shaded in. You just can't use -2 or 2. So in interval notation, from left to right, I can start at -infinity and go all the way over to the number -2. But you can't use -2, so we use a parenthesis. I can then pick up any number in between -2 and 2. And again, open dots means parentheses. I'm going to use the U symbol there, the word or. All right. And then I have one more stretch of numbers that I can use from 2 to infinity. But again, don't use the number 2 because that'll make your fraction undefined. This would be your domain. These are the numbers that you can use. These are the numbers, like if I were picking for a T-chart to graph this thing, I could pick like -3 and plug -3 back into this function up here, and I would get out an answer. I could pick 1. All right? I cannot pick the number 2, though, because if I pick the number 2, it's going to be a number divided by 0, and you can't do that. So that's what the domain is telling me. What numbers can I use to graph the thing?